Hi everyone, part 3, using substitution to solve a linear system of equations. So funny thing, on my video here, the title ended up on this page. On yours, your title is on the regular one, so I'm just going to flip. Okay, and now we're on the same page. So sorry about that. Okay, the second method for solving systems of equations is called substitution. Okay, we use algebra to determine an exact solution for the system. By using substitution, we transform a system of two linear equations into a single equation with only one variable. We then use what we know about solving equations in algebra to determine the value of that variable. The idea here is that we want one of the equations to be in slope-intercept form, so a graphing one, y equals mx plus b. Okay, a system is said to be set up for substitution if one of the initial equations is already in this form and the other one isn't in this form. Okay, the examples will demonstrate the process. Okay, so example 1, use substitution to solve these linear systems. Okay, again, neither one of these are set up for a true substitution. We have to do a little bit of work to get there. Now, in order to do this proper, remember we want one of the equations to be y equals mx plus b. Okay, so a y equals. Okay, and then it can be an x equals or an a equals or just one of the equations having one of the variables isolated. So, because neither of these are set up, we have to do a little bit of work. So we might as well pick the one that's the least amount of work. Now look at this guy. Okay, he is the only variable there that doesn't have a coefficient. See, this x has a 2, that y has a 4, this x has a 4. Okay, so this y is the only letter in this set that doesn't have a coefficient. So that one's going to be easiest to do. So y, so then the 4x comes across, so y equals negative 4x plus 5. So now we have one of our equations in mx plus b form, and then the other equation, we're not going to use this one anymore. We've already transformed him. So the other equation is in standard form. Okay, not a big deal what form it is, just we have one y equals, one that's not. Now look, we're going to do what's called a substitution. Okay, a substitution is replacing one thing with another. Think of sports. When you substitute a defenseman out in, say, hockey, you just substitute usually another defenseman in his place. Usually, or her place. Okay, so look, this y is the same as that y, which means I can substitute this y out with the negative 4x plus 5. Now, when I substitute, I always put brackets in, so watch this. We get 2x minus 4, and then the y is negative 4x plus 5. See, I just substituted the y out with that, because y equals that. Okay, so that's the substitution in the brackets, and then equals 7. So really, if I write in a different color, so this is 2x minus 4y equals 7. See, the y is just this part. Okay, awesome. So what that does for us is that gives us one equation with only one variable, the x. So now we have to use algebra to solve what that x is. So the 2x just stays. Now this negative 4 distributes to both of those chunks. So negative 4 times negative 4x is plus 16x, and negative 4 times positive 5 is negative 20. Okay, equals 7. Okay, so now we combine our like terms. 2x and 16x is 18x. Okay, and that 20 is going to have to move over, so plus 20 plus 20. So 18x equals 27. Okay, and then I divide by 18, divide by 18. And again, I'm assuming that you're just going to use your calculator for this, but we end up with x being 3, oh, funny, 3 halves. Okay, is what that works out to. Okay, so if x is 3 halves, now we go back up to one of our equations, and I guess I shouldn't have erased that. Okay, one of our equations, and usually it's this guy here that we've transposed, the y equals, okay, because we want we have to have the y part of the equation too. So y equals -4. We know now that the x is 3/2 plus 5. Okay, so -4 times 3/2. Excuse me. Okay, pardon me, plus 5. Okay, so let's see, -4, so that's 12. So this is y equals -6 plus 5, so y equals -1. So then our solution is x equals 3/2 and y equals -1. Now, the thing is, you always want to substitute that 3/2 back into the easiest equation. The thing is, you don't have to do that. I could have picked a different one to get the y value. So let's just use that top one just to kind of prove the point. So 2x, well, x is 3/2, minus 4y is supposed to equal 7. So 2 times 3/2 is just 3. So 3 minus 4y equals 7. Minus 3 minus 3. So -4y equals 4. Then divide by -4, divide by -4, and y equals -1. So we got exactly the same thing regardless of what equation we put it in. So again, doesn't really matter. Just go ahead and put one in. You never have to do it twice. And I'm actually going to erase this part because I'm getting into my space for the next question. Either way, the answer is x is 3/2, y is -1. Perfect. Okay, for B, now B doesn't quite work out the way that A did. All these letters, all the variables have exponents. They all have coefficients, so it's not going to be any easier to solve for one versus the other. So not a big deal. So let's, I guess let's take this first equation. Why not? Okay, so 5x minus 3y equals 18. So minus 5x minus 5x. So -3y equals minus 5x plus 18. Divide by -3 to everyone. Okay, and then y equals, okay, so the two negatives cancel. So 5/3 x minus 6. Okay, so that's what the y equals. So that's y equals mx plus b form. Okay, so not a big deal. Excuse me. Okay, so now we're going to take this y value, we're going to substitute it into the other equation. So I get 4x minus 6. Now I'm subbing out the y, right, because that y equals this y. So that y equals 5/3 x minus 6. Okay, and that's supposed to equal 18. Okay, so carry through. So -6 times 5/3. So that's going to be -10x. Okay, good. And then -6 times -6 is positive 36 equals 18. Okay, so 4x minus 10x is -6x. And I go minus 36 minus 36. Well, 18 minus 36 is -18. Divide by -6, divide by -6, and x equals positive 3. Awesome. So if x equals 3, then we go back up into, it doesn't matter, we can use any of the formulas, including this one, the y equals, which is kind of nice because y equals 5/3 times 3 minus 6. I don't have to do any algebra I've already done the algebra, right? Okay, so y equals, so 5/3 times 3 is just 5. So 5 minus 6, so y equals -1. Okay, and there you have that one. Awesome. Okay, so example 2, using a linear system to solve a problem. Okay, so create a linear system to model this situation. So Alexa invested $1,800. Okay, part at an annual interest rate of 3.5%, and the rest at an annual rate at 4.5%. After 1 year, the total interest was $73. Okay, So we're going to set up a system for this. So this is a really good one for a table. So we have the amount, or the total amount. Okay, so, and then we're going to have the interest. Remember, when you put money in a bank, you earn interest. Okay, so then we're going to have the amount, or the AMT, okay, at 3.5%. And then we're going to have the amount at 4.5%. Okay, and then, of course, the total. Now, the funny thing, I know what you're thinking. Well, why wouldn't she just invest it all at the 4.5%? How this works in the real world is you don't actually know the interest rate until at the end of the year. So the thing is, if you knew that the one was going to have a higher interest rate, well, then of course you would invest it all in that one. But you don't know, and you want to diversify your portfolio. And what that means is that you don't want to put all your eggs in one basket, because what if you did that and the investment did really poorly? Then you wouldn't gain anything, you'd lose money. Okay, anyways, enough of economics. So the amount at 3.5%, well, let's call that T. T for 3. Okay, and then the amount at 4.5%, let's call that F. Okay, and then the total, we invested $1,800. So that leads us to our first equation, T plus F equals 1,800. Now, how interest works, the only useful way to write a percentage is as a decimal, so 0.035. So that's the percentage. Okay, so the interest we earn is that number times the amount we invested, so times T. So the interest we earn is 0.035 T's. Okay, for the 4.5%, it's 0.045 times F. Okay, and we are told that our total interest earned was $73. So 0.035 T's plus 0.045 F's equals 73. Okay, so there is our system of equations. Okay, and then we're supposed to solve this problem. How much money did Alexa invest in each, or at each rate? Okay, now look, stay away from the decimals. Okay, we're in substitution, so we have to convert one of these forms into y equals mx plus b. Telling you right now, don't touch the decimals. Okay, so that means we're touching the other one. So t plus f equals 1,800. So tell you what, let's solve for t. So t equals, so the f comes across, so negative f plus 1,800. Awesome. So that's what t is. So now we're going to substitute that one into the other formula. Okay, so that's going to be 0.035. Then t is negative f plus 1,800. Okay, plus 0.045 f's equals 73. Okay, so we do a little bit of math here. Okay, so that distributes into there. So that's going to be negative 0.035 f's. Okay, and 0.035 times 1,800, pardon me, is 63. Plus 0.045 f's equals 73. So let's see, negative 0.035 f's plus positive 0.045 f's is 0.010 f's. Okay, and then let's see, we can go minus 63, so that equals 10. And then we just divide by 0.010. Divide whatever you do to one side, do to the other, and f equals $1,000. Okay, so if f is 1,000, we go up to this equation that we transpose, t equals negative 1,000, okay, plus 1,800, okay, so t equals 800. So all that means is Alexa invested $800 at 3.5% and $1,000 at 4.5%. Fantastic. So that is how you do that one. Okay, last example for this set. Okay, so solving a linear system with fractional coefficients. So solve this one by substitution. Okay, oh look, it even gave us the y equals already. So this one totally set up for substitution. Whatever, it's just fractions. Okay, so this y gets substituted in for that y. So 1/2 x, oops, pardon me. So 1/2 x minus 4/5 bracket. Remember, whatever you substitute, you put brackets. Okay, so 1/4 x minus 3/8. That's what the y equaled. Okay, and that equals -2. So see, one equation with only x's in it. The y's have been substituted out. So now this is just an exercise in algebra. Okay, and if you can't do the fractions in your head, that's totally fine. Just use your calculator. Not worried about this part. If you can do them in your head, oh, great. Okay, so really the 4's cancel here, and that's going to be -1/5 x. Okay, awesome. And then 4/5 times -3/8. All right, well, that just works out to +3. So, pardon me. Let's see, the 4 and the 8, so that makes a 2 there. So that's going to be -3/10. Sorry, +3/10. 3/10 equals -2. Okay, so again, with our calculators, we go 1/2 minus 1/5. So that's going to be 3/10 of an x. Then this is -3/10 minus 3/10. So -2 minus 3/10 is negative, and you just figure that out on your calculator. Okay, so -23/10 is what that works out to. Okay, so then we divide by 3/10, divide by 3/10. Okay, and x equals, well, whatever it equals, and that works out to -23/3. If your calculator is getting decimal answers for you here, on the TI-84 or 83, take your decimal answer and go hit the math button, okay, right below alpha, so math on the left-hand side, so math and then fraction. So math frac, hit enter, and it'll turn into a fraction. On the TI Inspire, if you hit menu number, so menu number 2, and then approximate to fraction is the second one down. So it's menu 2 will approximate to a fraction for you. Okay, anyways, the answer for the x is -23/3. Okay, and then we substitute into either equation. I'm going to use the second equation because it's less work. Y equals 1/4 x minus 3/8. So y equals 1/4 times -23/3, okay, minus 3/8. And when you type all of that in, you get -55/24. Okay, yes, the numbers are really nasty, but don't worry about it. It's not a big deal. The numbers are what they are. Okay, so that's how we solve it with the fractions. It's not a big deal. Okay, so that's it for this section. So I will need you to practice this, section 7.4 in your textbook, starting on page 425. Make sure you show your teacher when you're done, and I will see you next part. Thanks, guys.